Okay, so this video is solving polynomials. So I have this in grade 10 math, but in Alberta, it's often used as enrichment. So it just depends on what where you're taking math. But if you're in Alberta, you probably would maybe see this in grade 10, but you definitely learn this in grade 11. And it is an important skill to be able to do as you carry on with math. So with this first one, when it says solve the equation, notice that we now have our binomial set equal to 0. What this means is that we want to factor this side, and then you set each factor equal to 0 because we want to see what values of x would make everything equal 0. So we want to recognize that this is a difference of squares, so it would factor into x and x. The root of 81 is 9, and then one of these have to be positive, one of these have to be negative, and that will equal 0. Now, if this binomial sets equal to 0, 0 times anything equals 0. If this binomial was the one that was 0, same idea, then the whole thing equals 0. So now that we factor it, you can take each of your factors and set it equal to 0 and then solve for x. So here x can equal -9 or x can equal +9. So your solution is x is -9 and +9. That's what values work to make our equation equal 0. And we can plug it in and try it, and it will work out, and we can move on. So our next one, looking at 10x squared minus 90x. So first, again, we want to factor it. So we're going to pull out a 10 and an x from each term. So if we divide this first one by 10x, you're left with x. If we divide -90x by 10x, you're left with -9. And now all of this equals 0. So at this point, you can set all of your factors equal to 0. So we can say 10x equals 0 and x minus 9 equals 0. So your solutions here, so if we solve for x, divide both sides by 10, x will equal 0. Here, move the 9 over, x will equal +9. So x could be 0 or +9. And if you plug it back in and expand it out, those are the values that would allow you to get to 0. Now, moving on with just a little bit more work here, we have x squared minus 3x plus 2. So we're still going to factor it, but now we have to do the sum and product. So we're looking for what two numbers would add to -3 but multiply to 2. And then when we do that, we can break it up. The two numbers would be -2 and -1, right? So -2 times -1 would add to -3, multiply to 2. Then once you factored it, you take each factor and set it equal to 0 and then solve for x. So here x could equal +2 or x could equal +1. Again, take those solutions, try them, plug them back in. You should verify that that will equal 0. If I look at the next one, similar idea. Before I go to factor, I want to take out a common factor. Actually, there is no common factor. I'm going to have to do this by decomposition. So factoring by decomposition, that's where you break up that middle term. So we're still looking at sum and product. So we want two numbers that will add to the middle number, -10. Let me write it over here. We want to sum and product, add to -10, and then multiply to your first term times your last term, which is 9. So here we could use -9 and -1. So I'm going to write this, don't change the first part, 3x squared. I'm breaking up -10x to be -9x minus x plus 3 equals 0. So if you remember factor by grouping, once you've factored or split up that middle term, then you want to look at the first two terms and see what we can take out. And we can take out a 3x. And when you do that, you're left with x minus 3. Looking at the next two terms, we have a -x and a +3. So what we can take out is a -1. And when you do that from those two terms, you'll end up with a +x and a -3. And this all equals 0. The goal of factoring by grouping is now you have a common binomial, and we're going to take that out. So you'll have x minus 3, and you're left with 3x minus 1, and this all equals 0. So now that we've factored it completely, you can now take each factor. Now we want to solve. So now you can take each factor and set it equal to 0 and solve for x. So your first one, your solution is x equals positive 3. Your second one, once you move the 1 over, divide by 3, x will equal 1 over 3. So these are our two solutions. Again, we'll take those two solutions, plug them in, we'll verify that both of those values would give you 0. So you would plug them in individually, right? So the first time, if I want to check when x is 3, I'd have to put it 3 twice. If x is 1 over 3, we plug that in. So you do two separate calculations. Our very last one here just shows you that if we have our equation, but it's not equal to 0, we can make it equal to 0 by rearranging. So I'm going to move that 7x to the other side and the negative 3. And what you do to one side, you do to the other. So I'll have 6x squared, it was already there. I'm going to subtract 7x and minus 3, and this will all equal 0. And then I'm going to have to do the same thing. I don't have a common factor I can take out to make this easier, so I'll have to factor by grouping, meaning I have to break up that little middle term into two numbers that add to negative 7, but multiply to your first term times your last term, which is negative 18. So here you still have 6x squared, and then here we're going to have negative 9 and positive 2. So I'm going to write my positive 2x first. Sometimes it's helpful just to arrange in a way that you can pull out numbers. So if I do that, I can take a 2x out of my first two terms, and I'm left with 3x plus 1. And then out of my last two terms, I could take out a negative 3, and I'm left with 3x plus 1, set it all equal to 0. Now I can take out my common binomial, which was 3x plus 1. And when I take this out, I'm left with 2x minus 3. Okay, so I've done all of this work, and now I go to solve it. Now I take each factors, set it equal to 0, and solve for x. So from my first one, x will equal negative 1 over 3, and from the second one, x will equal positive 3 divided by 2. Once I get to this point, again, I can plug them in. So say I wanted to test that negative 1 over 3 first. I could plug it in right in for x, just how we see it here, and then I just would want to make sure that my left side equals my right side. Or I could plug it into the equation I rearranged and show once I plugged in my x value that everything equals 0. So there's other ways you can try it, but we still would hopefully verify just so we know we did it right. As always, I hope you found this helpful. If you did, please subscribe, and if there's any other video I could do, just let me know. Thank you for watching.